The objective of solving an equation is to find a value which makes the statement true. For instance, if we are solving the equation x plus 3 equals 5, what we are really being asked to do is find a numerical value for x which makes the statement true. In order to do this, we have to have all the variables on one side of the equation and the numbers on the other side. A variable is a symbol that represents a number. Usually, we use letters such as n, x, or t for variables. Solving an equation can be compared to balancing a scale. The first thing you need to do in solving an equation is to decide which is the number side and which is the variable side. Looking at our equation x plus 3 equals 5, the number side is clearly identified as there is only one number there. However, on our variable side, there are both variables and numbers, so we need to remove the numbers. Since we are adding 3, in order to remove it, we do the opposite. We subtract 3 from the left-hand side of the equation. In order to keep the equation balanced, which we must do, we take 3 from the other side. Since we have removed 3 from both sides of the equation, we are left with x on the left-hand side and 2 on the right-hand side. This means that x is equal to 2. Let's look at another example. If we add 7 to 3 times a number, the result is negative 2. What is the number? First, we form an equation which is 3x plus 7 equals negative 2. On the left-hand side, we need to get rid of the numbers. We are adding 7, so to remove it, we subtract. Of course, what we do on one side, we must do on the other. So we also subtract 7 from the right-hand side of the equation. When we do this, we are left with 3x on the left and negative 9 on the right. However, we have not fully solved the equation until the coefficient, that is, the number in front of the x, is equal to 1. Since on the left side our variable term is 3x, which means 3 times x, we divide by 3. And as usual, what we do on one side, we must do on the other. So we also divide negative 9 by 3. So the solution is x equals negative 3. We have now solved the equation. If the equation 2p plus 5 equals 7p minus 10, there are variables and numbers on both sides of the equation. When this occurs, we deal with each side separately. In these cases, you must clearly decide which side is the variable side. In this case, we will deal with the left side first. So first, we subtract 5 from both sides. We now have 2p equals 7p minus 15, which means the left-hand side only has variable terms. We now have to deal with the right-hand side in the same manner. Subtracting 7p from both sides leaves us with negative 5p equals negative 15. Since our aim is to find the value of p, we divide both sides of the equation by negative 5 so that the value of p is 3. Let's now take a close look at fractional equations. Just as with regular fractions, once we add and subtract, we must find the LCM of the denominators of the fractions involved. For instance, in the equation a half plus a quarter equals x over 12, we need to determine the value of x. First, we find the LCM of 2, 4, and 12, which is 12. Then, we multiply each term in the equation by 12. This gives us 6 plus 3 equals x. Our numbers are already on one side and our variable is on the other side. So we can now determine that x equals 9. Let's look at another example. 3 over 2y plus 2 over y equals 5. The LCM of 2y and y is 2y, since it is the lowest term that both denominators can divide into. Again, we multiply each term by the LCM, giving us 3 plus 4 equals 10y. 7 equals 10y. Dividing both sides by 10 makes y equal to 7 over 10. Sometimes the fraction has more than one term in its numerator. For example, x plus 3 over 2 plus 2x plus 2 over 3 equals 3. Just as before, we find the LCM of the denominators 2 and 3, which is 6, and we multiply each term by it. This allows us to get rid of the fractions. We now have Next, we group the like terms to give. Can you solve for x? Yes, we can get a fraction for an answer. So now we know how to solve simple equations, even those with fractions.